All right, ladies and gentlemen, today we're going to revisit the line of best fit. And you can see our essential question there is, how can I find the equation of a line of best fit from real world data? So we're going to pause the video here to make sure that you have that written down at the top of your Cornell notes. All right, so remember at the end of Unit 3, when we were studying statistics, we studied all sorts of real-world data. We measured our hands, we measured our heights, and we looked at that data to understand how to interpret it. And at the end, we started comparing two different kinds of data sets to see if there was a correlation. We compared our hands with our heights. We also looked at comparing the number of hours we studied with our grade in a class, and we looked to see if there was some kind of a correlation between them. So we're going to go back to that today, and we're going to revisit scatter plots. So just to make sure that we have our vocabulary down, a scatter plot compares two different sets of data to see if there's a correlation. Okay, and a correlation could have been positive, negative, or no correlation at all. So let's make sure we have that definition down. Also, we know that in real life, data does not make perfect anything, perfect lines, perfect curves. Our data was all over the place. We know the average height of a ninth grader, but we also can see when we measured in our class, we were all over the place because nobody actually fits the perfect average, or at least very few of us do. So real life data is messy, and we need to figure out how to interpret this. So we're going to revisit that data collection and the correlations to see how this is going to work today. So on the right-hand side of your notes, you can see already that we have these steps down for how to create the line of best fit. So the first thing we're going to do is we're going to plot all of our data points. And we're going to label our X and Y axis to let us know what this is. What is it that we're measuring? Are we measuring the size of our feet, comparing it to the size of our head? What is it that we're measuring? We're also going to make sure that when we label our axes with numbers, that they are numbers like a ruler, okay? We are counting by twos every single time, or we're counting by fives every single time. We're making sure that we're counting by the same increments, just like a ruler. So we'll plot those points, and then we need to find the mean point and plot that on our graph. So remember, the mean is the average. We're going to find the average of all the X values. We're going to find the average of all the Y values, and we're going to plot that point. It should be right in the middle of our data. So if it's way up high or way down low or somewhere off to the side, we know we've made a mistake. And then we're going to draw our line of best fit that is through that point and follows the correlation of the data that we have, either positive or negative. We're going to make sure when we draw that point, that line, that there is the same number of points on either side of the line, or at least as close as possible. Now, from there, we'll be able to pick two pretty points from the line that we just drew. It does not have to be an actual data point because we may or may not go through that, but we're just going to pick two pretty points, just like we usually do. And from those two pretty points, we can find the slope using the slope equation, which is y2 minus y1 over x2 minus x1. Once we have the slope, last thing we need to do is to find the y-intercept. Now we can tell from our graph, we can kind of guess where it's going to be. We can see where it's going to cross the line. We started at 0, we've gone backwards. We can see where that data point should be, but we want to do it mathematically to get an exact point so that we can use this equation to make predictions in the future. So finally, we're going to write that line. We're going to substitute in the slope from step 5, the y-intercept from step 6, and we'll have the equation of the line that we can use to make predictions with. So let's try an example. This example came from the textbook. It is not labeled with what it is we're actually comparing, and so this may not be the best example of what I'm looking for in your homework, but this is coming out of the textbook. So the first thing we need to do is we need to find the mean point. So we're going to average the X values. Now, since this isn't labeled, we're going to have to do some detective work here. So we're looking at the X values, and that's these numbers on this line. And so we can see our first X value would be 1. Then we have an X value at 1.5. We have two X values at 2. So we'd write down 2 twice. 2 at 3, 3 at 4, 2 at 5, 2 at 5.5, and 1 at 6.5. So if we write that down, it would look like this, okay? We're going to add all of those x values together, and we're going to divide it by 14 because there's 14 points on this graph. So what I want you to do is to pause the video now. I want you to get out your calculators. I want you to add these up, divide it by 14, get a number, compare it to your peers, and make sure you all come up with the same answers before we go on. So pause here. All right, if we've done this correctly, we should have 52 divided by 14. Now, if you didn't get 3.7 because we're rounding to the 10th, that means we've had calculator problems. You either didn't put everything on the top in parentheses, so it only divided 6.5 by 14, or you forgot to press the equal sign afterwards. So you would add everything up on the top, press enter to get a total, and then divide by 14. So we should have 3.7. Now let's do that again with the y values. So now we're looking at the numbers on this axis here. We can see we have 1, number 2, we have 3 3s, we have 2 3.5s, we have 3 4s, 3 5s, and 2 6s. So mathematically that would look like this. So we're going to write that down. We're going to do it in our calculator, making sure we understand how to get the point correctly this time. And we're going to compare with our peers to make sure we have the correct answer. So we'll pause here. All right, again, if we've done this correctly, we should have had 57 over 14. And in our calculator, that would give us a decimal, which we round to the 10th to get 4.1. So our mean point then, we got as the x values was 3.7, the y values was 4.1. We know if we've done this correctly, it should be somewhere right in the center of our data. And so when we plot that, we get, yep, there it is. We know that that's right about in the middle, so we've done this correctly. So from here, we're going to draw the line of best fit. Remember, this line has to go through the black point. It should have even number of points on either side of the line, so the blue point should have the same on either side of the line that we draw, and it should follow the general trend or correlation of the blue points. All right, so I'm going to draw mine here. Let's pause here. Make sure you have a ruler. If you don't, go and get one. And you're going to estimate and draw your own line. Remember, do not worry about going exactly through any points except for the black one. And we're going to pause here to make sure you can come up with it on your own. All right, here is the line that I came up with. It may not be exactly the same as yours. These are the points that I chose to go through, and I have about 5 blue points on either side of the line. Now I can also see that if I continue with this red line down, that my y-intercept is somewhere between 1 and 2. So when I get to that point, I know that's about what my number should be. So once have this line of best fit, what I want to do is find 2 pretty points. Now remember, these points do not actually have to be the blue data points. Okay, and you can use the mean point because we had to go through that one. But I'm going to find 2 pretty points to go through. And so looking at my graph, which might be different than yours, I'm going to choose point 1, 2, and I'm going to choose point 5, 5. Those are the pretty points that I chose. Okay, so you're going to pause here, and you're going to find 2 pretty points of your own, and you're going to write them down. Okay, from this point, we're going to use those 2 pretty points, whatever they are that you chose, and you're going to find the slope mathematically. Now remember, be careful, you don't want to do the slope staircase and just count the boxes because you may or may not have counted by ones. Maybe you counted by tens, or maybe you counted by hundreds. And so in order to make sure that we don't make that mistake, we're going to use the mathematical formula, which is y2 minus y1 over x2 minus x1, or the change in the rise over the change in the run. We're going to make sure we never put our x's and our y's together, and we're going to pause here to see if you can come up with the slope equation or slope on your own. You're going to compare with your neighbors and come to a consensus of what the slope is before we go on. All right, if we've done this correctly, if you use my points, you would have had the slope of 3/4. So remember, in our equation, this is the m. Now, all of these things are all things that we've done before. We're just putting all of the pieces together. We already knew how to plot the points. We already knew how to find the mean. We already knew how to find the line of best fit. We're just adding in now this equation because now we know how to find the slope. And the last thing we need to do is to be able to find the y-intercept. Now remember, we're going to do this mathematically because we want an exact point. So we're going to take that equation, y equals mx plus b. We're going to choose one of those pretty points that we used for the slope, and we're going to substitute in the y value, the x value, and the m value and solve for the b. So we're going to pause here again, choose one of those points, substitute it in, find the b value, and compare to your neighbors. Go. All right, here's what I have. Now, some of you may have had some difficulty because there were fractions. Remember, you do have a calculator, so let's use that strategy. So if you use the 0.12 and substitute in here, you were 3/4 from 2, and you got 1 1/4 or 1.25 if you're using your calculator. And that, looking at my graph, is about right. We said it was between 1 and 2, so 1 1/4 is about right. If you used the 0.55, again, you would have had 15/4, which is 3 3/4. So when I subtract 3 3/4 from 5, again, I get 1 1/4 or 1.25. So no matter which point you choose, you will get the same answer. So now that we've done that, all we got to do is write the actual equation of this line by substituting in the m, the slope that we found, and the b, y-intercept value we just found into the equation, and we'd have y equals 3/4 x plus 5/4, or 1 1/4, depending on how you wrote it out. So you can see all of these things that we're doing are all pieces of stuff we've already done this whole trimester. So we're going to put it all together in your homework tonight. So for your homework tonight, you will be doing the textbook, page 336, and you'll be doing numbers 7 through 9. It is expected that you will use graph paper. So you're going to write your own x and y axis, you're going to label them, you're going to plot those points, and then you're going to show the work mathematically for your slope and your y-intercept to come up with an equation. Now, each of you might draw your lines slightly differently, and so we may not all come up with the exact same equation, but they should be fairly close. So at this time, you'll have time to use the textbooks at the back of the classroom. There'll be graph paper passed out that you can use, and it's expected that you're showing all of your work and using your time wisely so that you may not have very much homework to do tonight if you can get it done here in class.